We are going to talk about an interesting case, an interesting fact, and we will prove it, that the idea that the eigenvalues of a positive definite matrix, and important to note that I'm going to talk about positive definite, but in the same manner, in the same proof, right? Just a little bit of change, you can prove things for a positive semi-definite, negative definite, negative semi-definite matrices. So we're going to talk about eigenvalues of a positive semi-definite, positive definite matrix. And we are going to see that the eigenvalues of a positive definite matrix are all positive by definition. So how can we prove it? We'll start with the basics, and the basic idea of a positive definite matrix is by definition that the inner product of ax and x is always positive for every vector in the space we are. So this is a fact for a positive definite matrix. Now, when we are looking about eigenvalues, of course, it satisfies this. This is the definition for an eigenvalue, where v is an eigenvector, so lambda is the eigenvalue corresponding to v. Now, when we are looking again on the basics, we are talking about the inner product between av and v. We know that, as we said, it's always greater, not equal, greater than 0 by definition for a positive definite matrix. So AV, we know that it equals lambda V. Therefore, we can change this by lambda V. Now, we can take lambda out because it's just a scalar, and we are left with the inner product between V and V. Now, the inner product between V and V for a positive definite matrix is, with all of this, is always positive, and therefore we can look at it as the norm of V. Okay, so this is positive, as we just always, all what we did is going from this, and this we know that it is positive by definition for a positive definite matrix. So this is also positive, and therefore you can look at it as this. Now you can divide by the norm, square norm of V, because you know it's not 0. Why it's not 0? Because we are talking about an eigenvector. And by definition, an eigenvector is not the 0 vector, by definition for an eigenvector. So you can divide it. So it must be greater than 0, greater or equal the norm. And because it's an eigenvector, the vector is not the 0 vector, so the norm cannot be 0. So you can divide by it. And when you divide, you are left with lambda. And with lambda, or what is left is that is equal than, is greater than 0. And as we said, we did it for an arbitrary eigenvector and got an arbitrary eigenvalue, so it's true for any eigenvalue. So all the eigenvalues of a positive definite matrix satisfies that they are positive, namely they are greater than 0. Okay, so the conclusion is every eigenvalue lambda of a positive definite matrix A is real and strict positive. Okay, thank you very much. If there are mistakes or correction, please tell me. Thanks for ChatGPT for organizing the data for me, and thank you very much, and that's it.